and welcome to this edition of the NGINX Community Chats. During our chat, you get to hear about some of the things open sourcey, meet some of the people behind open source, both inside and outside of NGINX and F5, and maybe even learn something new. I'm Dave McAllister, open source technologist for F5 and NGINX, and today we're coffee clatching with Chris Fallin, though I suspect we're going to be getting into the bits and bytes of some projects as well. And remember, Coffee Klatsch is German for coffee and gossip. So these are very informal chats. Thanks for joining us today, Chris. Tell us a little bit about yourself and what you do here at F5.
Yeah, thanks for having me. I'm really happy to be here. So I am a senior architect at F5, as my title should say. I have been here since November, and I work in the office of the CTO, Octo, which is kind of the R&D arm of F5. On all things WebAssembly, really is the job description. And in particular, we want to use WebAssembly to add sort of a new layer of programmability to all of F5's products. So that includes NGINX and some of the other product lines. And so the job is kind of like half open source. We maintain an open source WebAssembly engine, which I'll talk more about, and half integrating that into F5 products and advising product teams and all of that good stuff.
Yeah, you mentioned one of the magic technologies with WebAssembly, and I have a blog from my 2021 now that basically said these are the 5 technology you have to learn by 2025. And WebAssembly was, I think, either number 1 or number 2 on my list. But it's really a game changer for high performance coding. What really gets you going about the potential for WebAssembly? And why did you choose to put all this time and effort in these projects around WebAssembly?
Well, why time and effort? Because it's fun. So I'll tell you why I like WASM so much. So I'll give the product level answer first. The product level answer is that it's this nice meeting point between a bunch of different languages. So you can target WebAssembly from Rust, C, C++. So all of your legacy code, in addition to a bunch of newer languages. There are compilers from JavaScript to WASM, Java, Kotlin, all of the languages you would expect, Python, and it is sort of this nice portable format then that once you have that, you can run it in a lot of different places, in the browser, on the server side, embedded environments, which I can talk more about. The thing that excites me, though, as a technologist, as a compiler engineer, is that it seemed to have gotten a lot of trade-offs right and kind of learned from past bytecode formats, right? So the JVM, the Java Virtual Machine, is a common comparison point, been around for 30 years now, and people ask, isn't WASM just reinventing the JVM? Well, it kind of is, but it also chose to do different things. So, for example, has a low-level byte addressable memory, and that makes C, C++
Mhm.
legacy code work a lot better. And actually takes the security boundary seriously, which is the other big thing that sort of enabled, all of the applications. And that came out of being born in the browser environment where all code is untrusted and potentially malicious. So for that reason, I feel like it is a new exciting thing that got a lot of trade-offs right, and so opens up a lot of possibilities as a result.
Yeah. Well, as a many times removed compiler engineer myself, and I think the last compiler code I worked on was GNAT for Ada 95, which is quite a ways ago, about the same time that JVMs came into being, very honestly. Back in those days, we did a lot of cross-compilation targeting, but it was language specific and system specific.
Mhm.
And it feels like WebAssembly has changed that model a lot.
Yeah. So one of the interesting things that WASM did was, unlike other sandboxing technologies, and actually like the JVM in this particular way, it said that certain language primitives are fundamental and built into the VM. So in particular, functions, function calls, the call stack, and now new extensions for exceptions, and garbage collected objects, a few other things are built in. And so if you're able to adapt your language or write a compiler from your language to use those built-in primitives, it actually really is portable. And not only portable, but it's polyglot, right? So you can write some of your code in, say, JavaScript, and some of your code in Java, and some of your code in Rust. And in theory, they should all be able to call each other with just ordinary function calls,
Mhm.
passing shared data back and forth. And so that's kind of like one thing that it got very different, right? As opposed to, as you say, when you have a cross compilation, sure, you can compile your Ada or C or Rust or whatever for any processor architecture, but it's kind of a n times m problem, right? You
Right.
have to build the glue between this language on this processor and that language on this processor, and do that for every combination. So
Yeah.
WASM is kind of a nice improvement there.
Yeah, we didn't have a choice. But when we were in the Ada space, when you're cross compiling from Ada to Ada. We had to worry about the target systems. At that time, the DoD mandate for man in the loop stuff, it had to be Ada. There's nothing else you could allow was allowed. So it was kind of cool. So, not that I've been stalking or anything like that, but I do notice that when I ping you, this thing called Cranelift shows up. So
Yeah.
what the heck is Cranelift?
Yeah, so it's a compiler is a short answer.
Okay.
And I'm a compiler nerd, so it makes total sense that I would, be involved with it and like it so much. It is the JIT compiler backend for WASMTime. And WASMTime I can talk more about, but that's the WebAssembly engine that we here on my team work on, open source project. And so Cranelift is the thing that actually takes, well, it's an intermediate representation that's from the WASM, but it's close to the WASM, and compiles that to the actual native machine code, right? So WebAssembly is run as compiled machine code on whatever platform it's running on. And so it's an optimizing compiler. And so you can compare it to like, LLVM, for example, or GCC's backends. It's a lot simpler than either of those, though. So it was written actually as a potential new backend for Firefox. It was born at Mozilla.
Okay.
Where
Hmm.
I used to work as well. I wasn't involved in the very beginning. I got involved about 5 years ago in 2020. But over time, people discover that, okay, we have this portable, reusable compiler library that's very general, and so we can use it for things like building a WASM engine when WASM became a thing. And so that's actually its primary use case now. And yeah, I can talk a lot more about the sorts of things I built in it. But I was tech lead from 2020 to 2022, did it full time. I'm still hacking on it. Just last month, I added support for exceptions, which is kind of fun. But yeah, it's been a really interesting project and has led to a lot of sort of novel work, I think.
Yeah. Yeah. You mentioned a couple of pretty important things between WASM time and actually Cranelift as well. And I may touch on that a little bit further here. But when we're talking open source and you're talking to the open source side of NGINX, very honestly here, you've had to deal with a lot of challenges in these projects. What's it like driving an open source project like Cranelift?
Yeah, so I think there are a few levels of challenge, right? There's like just the open source dynamics, and then there's like in a corporate environment, which has been the case for me for the time I've been involved. So first of all, just the open source dynamics. When you're tech lead, you're kind of the problem solver of last resort, right? And so like there's ugly, grungy stuff, and someone just has to fix it. So like that's annoying. But the main thing is just getting people aligned, right? So getting the right people involved and getting incentives aligned so that, okay, you want to do this, quick transactional thing, just submit your patch, hack it together, make your use case work, and then disappear. My interest as a maintainer, or as a tech lead, or long-term involved member of the community is I want it to actually be sustainable and improve over
Mhm.
time and pay down our tech debt and all of that. And so getting people aligned and involved in the right way, and getting them to be continued to be involved is really the main challenge there. And then I mentioned the corporate side as well. So I was involved in this both at Mozilla and then at Fastly, where I was before F5 and now at F5, actually all three companies working on Cranelift. And getting investment or getting the space to do just sort of like, again, the low level, grungy, continuous maintenance stuff is really the hardest part, because corporate
Right.
planning, capitalism in general actually works in terms of like, we have this project, let's throw money at it, rather than, okay, this is just keeping the bridge from falling down sort of expenditure.
Mhm.
So, you make arguments, and some management understands better than others. F5 here is actually quite good. They, are employing my team to continue to maintain WASM time and Cranelift. But yeah, that's kind of one of the big challenges.
Yeah, yeah. Just sort of a side mention because it's important. Wasm Time is under the Bytecode Alliance, and Nginx was the minute we discovered Wasm Time and a open source project called Unit, which was our first implementation for Wasm as a backend. We jumped into the Bytecode Alliance. We believe that alliance, very honestly, is driving the future and directions of the actual practicalities of WebAssembly, where W3C is driving the standard itself. But it's really important for us to be able to give back, and your team is helping us give back to this open source project set.
Yeah, it's been fantastic.
Yeah, so Cranelift, and this is cursory. I've just heard you talk a little bit about it, but it has this weird dynamic. It's both simple, but it's also focused on speed. how the heck did you manage to solve that technical problem?
Yeah, by banging our heads against the wall enough time, right? Enough times. So I think that in any field that gets really established, and compilers are very established, as you said, you
Yeah.
worked on it, a long time ago. It's been in a field since the 1950s. People get stuck in their ways, and so there's, I think, always an opportunity, or often an opportunity, to sort of look at things and say, can we do this in a different way? And so what we did with Cranelift, first of all, we realized we're a much smaller team. So like the main competitors are, either the JIT engines, so like V8 or SpiderMonkey,
Yeah.
or LLVM or GCC. We have a much smaller team, on the order of like 3 to 5 full-time people, depending on the year, than any of those projects. And so we can't just compete on brute force and just say, okay, we're gonna pull out all the stops, implement all the optimizations, implement all the tricks. So we kind of took a step back and said, where can our time make the most impact for the least effort? And so we implemented kind of a basic level of optimization that works really well for most code. And then the other thing that we did is we were smart about getting involved with like new ideas that were coming out of academia. And so like I implemented this thing called eGraphs in the Cranelift optimizer that is a new way of sort of combining all of the mid-end optimization phases in a way that actually works pretty well, and not just took the academic idea, but kind of extended it to make it faster as well. So yeah, a combination of new ideas and just the right level of focus, right? There's this trade-off curve. You can spend more time during compilation to create better code. And so just finding the right way to tune that is the trick, basically.
Yeah. So, academics versus the pragmatic of open source. How do you balance those two?
Yeah, that's an interesting question too. So I don't think I've mentioned I have an academic background. I got a PhD in compilers, and to some people that would disqualify me from ever writing real production code. But I've always felt that I'm kind of weird and in the middle. I've always been a hacker. I was programming long before I got into like formal ideas. I think that the way to think about it, if you're in industry, is that there's this huge population of people who are really smart and have studied the problems in depth. And so you need to at least, sort of respect that there is that expertise. I think there's this tendency, especially in like move fast and break things tech culture, to say, oh, whatever, I can just hack it up, right? I can just figure it out. I'll just brute force it. But actually, no, there are actually deep problems that are, even NP complete sometimes, or
Yeah.
whatever. And so use the expertise that's there, read the papers, read the background, talk with people. But then also academics sometimes miss the last mile of implementation, right? Or of making it real, not just in terms of robustness and covering all the edge cases and all of that, but actually optimizing it, making it fast. And so I think it's actually a really productive place to be in the middle, where you kind of like pull new ideas, pull inspiration, but then you also sometimes even feedback problems and say, okay, well, it didn't quite work in the real world because blah, and then that leads to like new ideas as well.
Yeah, that's. I actually, believe it or not, I saw a cartoon strip today where the final comment was, "Don't let perfect get in the way of good." And it kind of feels like that's what you're describing here. Is quite often we worry about the academic side. I taught at University of Houston for a while. The academic side, where we need to be the correct answer, and the correct answer must be correct enough that it doesn't change. Whereas that can take you forever, and particularly in compilers, which are constantly changing, we can't ever say that we're finished. At least to my best knowledge, no one has ever created the two principal things: do what I mean and hear what I say. If they ever get those two commands to computers, who needs a compiler? So
That's
for
right.
that.
That's right.
So WASM has also caught on across a lot of companies, and I have my own personal reason why I was fascinated when I first saw it here. But there's a lot of companies using it. There's a lot of products out there using it. And most of us, we don't know. But you're kind of on the inside. What's your favorite example of a product using WASM?
Yeah, well, it's so as I mentioned, it's portable. So once you have the WASM, you can run it in the same sandbox, from giant computers down to tiny computers. And so there's that axis, there are other axes as well. So everyone knows about WASM in the browser. That's where it was born. A lot of people have probably heard about WASM on the server as well. So you can write server-side functions in WASM, and that's much more efficient than full virtual machines or containers. In the Bytecode Alliance, actually, we've seen some users even use it in the embedded space, in
Ooh,
surprising applications like TVs or cars, right? So you might want the ability to take, new logic, new updates to some kind of application and ship it over the air, or ship an update and install it more easily, all the way down to like embedded systems for robotics, right? Where you might have some custom, high performance, even near real time, loop that's running and controlling a giant robot arm or something. So it really is like this universal tool where if you need pluggable code that's portable and you need to be able to use, code that's compiled from any of these languages that can target it, it can be applied in all these places. It's pretty cool.
Yeah, that's actually, the language thing is also really important because generally speaking, most developers focus on a particular language and that's the language they work in. But quite often we have teams working in different languages and being able to glue them all together is kind of really cool. Okay, we're going to shift gears on you real hard here, right? This because we always ask all of our guests this question. What's your favorite non-work adjacent open source project?
So it depends on how you define work adjacent, because I use both of these that I'm going to name in my work. But one is an oldie but a goodie. I'll say the Debian operating system,
Mhm.
GNU Linux, right? I use it on many of my machines. I've used it since I was a kid. I think that like they did a lot of things right early on before it was cool, kind of. They focused on the social side mainly. So
Yep.
the free software guidelines, the manifesto, and getting the values right, and then focusing on building up the community and having the structure of maintainers and all of the communication infrastructure and all of that. Oftentimes people think, okay, it's just about the code, but it's not. It's about the people developing the code and making sure that's sustainable. And then the other one is Rust, the language. Has, I think, done a really, really good job of scaling. It's really impressive to see how it started from just essentially a research project in Mozilla. It was before my time, before I was there, but really talented team. Started with a really strong base, but then they figured out how to have like RFCs and discussions and all of these things that let the work fan out to this huge community of thousands of people who have built like a really impressive, thousands of human years worth of work level foundation that everyone can use. So yeah, both I think are really inspiring in those ways.
Yeah, we've talked a lot about open source and you've got quite the background in here. But what would be your recommendations for somebody who wanted to get started with open source?
Yeah, I think the thing that's most motivating, right, is to have a problem you're trying to solve.
Right.
And so start with, just whatever you're trying to do. Maybe it's like home automation. You want this light switch to control this camera, whatever, right? I don't know why a light switch would control a camera. Anyway, something, right? Or you're trying to build a website that does a thing and you need a package that has a certain UI feature or whatever. Go looking for projects that might, solve that problem. And maybe there isn't one that's exactly right. A lot of times, especially sort of in the long tail of open source projects, it's just a little one person thing. Someone has posted a project on their GitHub and, try to use it, fix it up if it doesn't work, and submit a pull request. And more often than not, people are friendly and they'll be like, hey, cool, you improved the thing. Speaking as a maintainer, also the thing I try to do when people come and ask for features or improvements or whatever is I try to turn it around as often as I can if it looks like it'll work at least, and say, great, pull request welcome. Like here's where I would go in the code and implement that. Uh, and so I think that's a really good way, that's like intrinsically motivated, right? You want the thing, and so you're going to go and build it, and then hey, by the way, you can be part of the community and contribute that good back to everyone else. So yeah, I just, whatever you're interested in, there's probably some open source project that's relevant to it. If your interest is, computing related at least.
Since there's like 300 billion different repos on GitHub, there probably is something somewhere for everyone for
Yeah.
this. So, how does someone get started with Cranelift? Where is it?
Yeah, well, so it's on GitHub. It actually lives in a monorepo with WASMtime, same repository. So github.com/Bytecode Alliance is, as you mentioned, the org that we're under, WASMtime, and just use it. If you want a compiler backend, it's probably a good choice if you're working in Rust, or we have yeah, bindings for other languages with WASMtime. Anyway, use it and see if it works, and if it doesn't, or if you want to optimize code, we have lots of starter issues. We're happy to talk. We also have a Zulip, the chat platform, a Zulip instance. You can find linked from the repository. Come talk to us, and yeah, there's a lot of interesting work to do.
Chris, this has been really fascinating, making me remember all of my wonderful compiler issues and unfortunately operating system issues as well because of doing things like bytecode alignment on MIPS processors.
Oh boy.
Um, Transferring code from Baxis, which you don't care where the bytes are, to even alignments on MIPS for that. So thank you so much for sharing your thoughts, your projects, and just your insight.
Of course.
And to our viewers, thank you for joining us today and meeting some of the people behind the scenes and getting some of the feel for passion of open source here at F5 and at NGINX. If you've got your own thoughts, your own ideas or just want to ask a question, feel free to leave them in the comments below or join us on the NGINX Community Forum. And until next time, may the open source be with you.